All right, so let's look at this and then let's implement it. Hopefully you had a chance to implement it on your own. If you remember what count's gonna do, right? Count does two things. One, it tells you how many things are in the array in a partially filled array, all right? And two, it tells you the index that we're gonna insert into next. Notice that when count is 0, that is also the index that we're going to insert the value into because there's currently nothing in the bag. So 0 is not only how many things are in the bag, but also the next index we're going to insert into. And count allows us to do that. So in a partially filled array, we're always inserting at count, okay? In this case, we're not going to, we'll check the reserved case in a second, but right now, what we're going to do is we're going to say, well, I need to insert this thing. Sorry, we're in array bag mode. We need to insert this thing at count, right? So target needs to be inserted in count of our bag array. Let's do that real quickly. So bag array, and the index we're going to insert it in is count equals target is what the user wants to insert into this. Target, okay? And then at this point, we have one thing inserted into the array. So whatever target was 15, whatever target happens to be is chilling here at 0, right? If it was 15, that's target now, right? And what we're gonna do is we gotta update count, okay? So we can say count equals count plus 1, all right? And this would work, okay, if we never ran out of space, all right? We'll get to that in a second. Let's do linked list bag now. And what's linked list bag gonna do? Well, we talked about it over here. The first thing we need to do is we need to point whatever, we need to make a new node, right? And then we need to point its next to whatever head is pointing to. And then we have to point head to our new node. So this is 3, right? And that's where we're starting, is head pointing to null or head pointing to some node. It really doesn't matter, okay, what head's pointing to. And that was something you had to figure out on your own. Why doesn't that matter? Why don't these cases matter? So let's talk about how we would do that, okay. So if someone wants to insert target, we first have to make a node. So we can say node to insert equals new node, and we'll just call the default constructor. All right, there is no constructor, so the default constructor will just give us space for data and next. At this point, we can set data and next, right? So to insert dot data equals target, right? And we can set the next of this thing. To insert dot next equals, well, we need it to point to the same thing that head's pointing to, because whatever's head is pointing to, since we're inserting at the front, which is the easiest place to insert. So we're going to just insert in the front because it's the easiest place to insert, right? Reason being, no matter how big it is, it's always O of 1 to insert in the front, right? So we don't have to cycle through the whole thing. We could just insert right at the very beginning. So we'll make next equal to head. That's a shallow copy. That means next is pointing to the same thing head's pointing to. If head's pointing to null, now the next of toInsert points to null. Okay. If head is pointing to a node, then the toInsert of next points to a node. And then finally, what we're going to do is we are going to point head to toInsert. Okay. Let's make this abundantly clear how this code, what this code looks like, okay? So we started with head pointing to null, okay? And that was from the constructor up here, okay? So that occurs when we say in main, for example, ll bag, my bag, equals new ll bag, okay? And so now head is pointing to null, all right? And then if we say my bag dot insert and pass in some value here, whatever value you want to pass in, 15 or whatever, what's going to happen? Well, let's see if I can do this to make it abundantly clear. Okay, so head is pointing to null. Okay, and then what we're going to do is we create a new node. Okay, cool. So toInsert points to a node on the heap, right? Because we use new there. It's a new memory. It's an object, right? Node's an object. And it has a data and it has a next, which is a reference to the next node, and data is a primitive integer. Okay, these aren't set right now. We don't know what the values are. Okay, so it's up to us to set them. Since node is a inner class, we can typically just set the fields directly, and that's what we'll do here. You could also make a getter and setter for node and make it a giant thing, but we don't have to, and that's so we'll use it because a node's only going to be used by the linked list. Okay, the linked list bag. So we don't have to make it so that it's externally accessible. And so we're going to say toInsert.data equals target, whatever the target value is being passed in, right? So that sets the data to whatever the target is, equals target, right? And the next is being set to whatever head is referencing. It's a shallow copy. Remember what shallow copies look like? That, okay? So toInsert is pointing to this on the heap, right? And next from this one is pointing to null, okay? And then finally, head equals toInsert. Well, that's another shallow copy, and that does this. All right, so head is pointing to this, and this is pointing to null, and so our private variable head, the only thing that's in our linked list bag, now has pointing to this node here, okay? And so we've actually completed the linked list implementation of insert because there is no capacity in a linked list. There's no notion of capacity, okay? One final thing, so this is going to prompt the next thing you have to do, which is deal with the capacity in array bag. And the way I want you to do this is we can just think of another, this is what we do in C++, and I think it'll be useful to do this here, which is let's have a void function called resize, okay? And what we're going to do is we'll take in a new capacity, okay? So we're going to resize the array and take in a new capacity, all right? And so here what we're going to do is we're going to say, well, check if we're at capacity. If we are, call resize with the new capacity, okay? Which should be double the old capacity, okay? Remember, capacity is just the length of the array, right? So right now the capacity is 4 because that's the length of it, okay? So don't hard code it to 4. You've got to use the length of the array, all right? And so then we can create an array with the new capacity. Okay, and make it double the old. Okay, so we're calling resize with a new capacity that's double the old capacity. So the length of the array times 2. We create an array with the new capacity, okay? And then we copy over the elements of the old array to the new array, okay? And then finally, we make the bag array reference this new array, all right? So what we're looking at here when we resize this thing is we're saying, okay, someone inserts 4 times. So target, 1 and target 2, they call it again, right? So they call insert 4 times. target 3, and target 4. Okay? What's happening here? Well, now we are at capacity. Okay, so now we're at capacity. That means the amount of slots we have for this array, right, which you can get from bagarray.length, equals, well, what? The count of this thing, right? Because we have 4 things in here, and the bag array only has slots for 4 things, so the length of it is 4, right? And so when they equal each other, we're at capacity. It's time to call resize. When we call resize, we create a new integer array that's double the size of the old one. Okay, and we know the size of the old one through length, right? And that's good. So it's double the size of the old one. Okay, and then we've got to cycle through and copy this over. Okay, and I say cycle through on purpose because it drives me crazy when people do not understand the intimate relationships between arrays and a certain structure, a certain control flow cycle thing. I don't know. You get it. All right. So now we copy all this over, and now the final thing we do is whatever this is. Let's say we called it temp or something, and so temp is pointing to an array on the heap, right? And remember, to create this array, we have to use new. We've created an array of 4, right? And so we've got to double the capacity. Final thing we have to do is we just shallow copy it. We just take bag and we point it to the same thing as temp. Okay? And once we do that, we basically had our old bag that had 4 slots, and then what we did was we made a new bag that had 4 more slots, that's double the size. We filled in the old bag with these slots, and now it's like we're ready to go, right? Because what's gonna happen is we are going to be able to grab something at index 4, put something into index 4 now, okay? We can put something into index 4, and then we can update count, and we're back in business, all right? Keep in mind that you have to make it based, you have to make the new bag size based on the old bag size. So the next time we resize, it has to be 16, and the next time we resize, it has to be 32. And how do you do that? You always double the current bag size, okay? And you do that by passing in 2 times new capacity and then making an array with the new capacity. Okay, that's going to be our plan. But you could pass in something different. It just wouldn't be as efficient. The reason we double the size is because copying things over like this is a time-consuming operation and memory-consuming operation. Okay, and so the more we do it, the slower the program's going to be. And so we try to make it so that if we're doing it a lot at a certain size, we double it. If we're still doing it a lot, we double it again. And hopefully we get to a point where we have a big enough array that'll handle the additions in our program. All right, so I'm gonna give you a chance to work on resize, and then I'll see you in the next video where we'll look at the solution to resize, okay?